Assalamualaikum and good day to my lecturer, Dr. Abdul Halim bin Abdul Latif. Thank you for spending your precious time to watch my paper review presentation. My name is Aishah and I have chosen diffraction migration as my topic for paper review presentation. Today, I will first cover on the introduction, problem statement, objective, main analysis, and lastly, conclusion with some recommendation for future direction. Moving on to the first topic, which is an introduction. Generally, diffraction will be ignored and considered as interference noise in conventional data processing. However, the recent study found that seismic diffraction could be responded as small-scale inhomogeneities or discontinuities geological features such as fault and fracture, which play a vital role in the exploitation and development of oil and gas. Therefore, by applying migration to the diffraction image, then it can delineate the correct geological structure as well as restore the reflector point to its actual position. Diffraction, also called as apparent reflector, which resulted from scattering of the body wave. The migration in the imaging process can be carried out before or after stacking process. Therefore, in this paper review presentation, the student will discuss more about the diffraction migration in enhancing the quality of diffraction image. Now move to the problem statement. Nowadays, there are many imaging problems exist that are related to produce a correct position for seismic attributes, complex structure, as well as subtle stratigraphic features in the seismic section. Therefore, this paper review presentation will suggest any suitable advanced method to enhance the diffraction migration or imaging in order to delineate the correct geological structure. Let's move to the main objective for this paper review presentation. The first one is to utilize the knowledge and understanding of diffraction migration method in delineating the complex structure in seismic data. Second, to evaluate the significant gaps between conventional diffraction migration method and advanced discovery of diffraction migration method. And the last one is to find out the current debate about the method chosen for diffraction imaging. Now, let's move to the main analysis of this paper review presentation. For the first subtopic of main analysis, which is about the main people working in doing the diffraction migration. There are many researchers have done their research study about the diffraction migration in seismic imaging. For example, Nangulan and Subarsha in 2014 has used the kickoff pre-step time migration for superimposing diffraction effect on 2D seismic multi-channel data at Flores Sea. Followed by Varshay et al. 2016, also used the kickoff migration to image the diffraction with the effect of different frequency with different migration aperture. The main purpose of the research study mainly focused on imaging the diffraction in order to significantly improve the detection of small-scale fault, salt dome, and other heterogeneity structure in seismic section. Their common process method is conventional kickoff migration method. Nowadays, many researchers have discovered more advanced techniques in enhancing the image quality of fault, fracture, and crust using the diffraction image. The newest discovery of advanced methods are using the plane wave distortion method for diffraction separation, and the second one is using the coherent diffraction imaging. Plane wave distortion method also can be used to separate the diffraction event from specular reflection prior to migration. Next, PWD method will be further combined with the time migration deep angle gather that derive from the kickoff phase angle PSTM for imaging the seismic diffraction. Lin et al. 2017 proposed to use the deep angle gather domain because it is a convenient domain for migration velocity analysis to image the diffraction. Parshay and Ghosh 2018 also used the PWD method with an improved finite difference design in their research study in order to maintain the diffraction information and further migrate separately. Okay, this is an example from Lin et al. 2017 where they made a comparison between the diffraction events with reflection events. The reflection event is constructed by using the conventional PSTM method. As you can see here in figure 1, the energy of reflection are much stronger than the diffraction, which lead to mask the diffraction information. Okay, this is a reflection event, and here is diffraction event, but cannot see the diffraction events. By applying the PWD method, it eliminated the reflection and enhanced the diffraction event by constructing the deep predation error filter with reflection locus loop. Then, deep angle gather are generated to achieve the velocity analysis for diffraction by flattening the diffraction event using this equation in order to obtain an accurate migration velocity. In figure 3 show the result of migration velocity model for diffraction, and that is constructed by flattening the diffraction event in the deep angle domain. And the right one in figure 4, there is the result of velocity migration for reflection by using the conventional velocity analysis. In time migration, the migration velocity for diffraction is smaller compared to reflection because they have different travel paths. Due to the long travel time of the diffraction, the migration velocity for diffraction becomes small compared to reflection. Okay, this is the result of applying the PWD method with the time migration deep angle gather. As you can see here, the diffraction image profile in figure 5 generally show the direction of target strata and provide details of accurate location of the fall. However, the reflection image profile using the conventional method only describe the large-scale geological profile, which lacks of the detail about small-scale discontinuities. The blade arrow show that the diffraction is not perfectly collapsed, which can cause the problem in locate the small scale accurately. While by using the PWD method, it can locate the correct location of the fault. Okay, this is another example from the Lin et al. 2017. In figure 7 show gather low signals to noise ratio, which indicate the difficulty of velocity analysis and imaging the diffraction. By applying the new scheme method in figure 8, it has resulted in performance of revealing and locating the location of small fault and potential of hidden structure compared to the conventional method in figure 9. The signal noise to ratio also increased by using this method. The second new discovery is coherent diffraction imaging. Coherent diffraction imaging seeks directly to incorporate wave field coherence in the imaging workflow and can be viewed as a prerequisite for migration type imaging. The imaging can be divided into two domains, which are image and data. In order to properly differentiate between these two domains, hence image-centered approach will be denoted by focusing, while data space will be denoted as projection. Coherent focusing will evaluate the wave coherence during gradering stage in image space. It also known as a wave equation migration, while projection evaluate the data coherent and then back project with the help of extracted information. It is also known as time reversal imaging. Okay, this is an example. In this white circle indicate the width signature of erosion that can be clearly seen in coherent diffraction image, but mostly hidden in the conventional migration. Moving on to the other example, okay, this is an example of unprocessed data input from a marine seismic single channel that carried out near Santorini in the NGC. Okay, by applying the coherent diffraction imaging, the intricate fault and fracture level are revealed. Okay, this is a close-up image from the figure 13 where 7 faults are observed. Aside from faulting, erosional unconformity and interference between sediment and crystalline basement also are recovered. Okay, this is another example from conventional kickoff migration. For the figure 16, this is the result of coherent diffraction imaging where lateral structure resolution up to 200 meters was achieved which a set of quasi-parallel faults become distinguishable in the lower rightmost part of the diffraction image. Okay, now let's turn into the significant gaps of the research. Firstly, I will explain about the procedure for every method because every method have different workflow procedure. Okay, I start with the kickoff migration method first. It start with raw data, followed by pre-processing, next velocity analysis, NMO correction, kickoff, pre-step time migration, and lastly PSTM session. Kickoff method is conducted during the pre-step time migration. Okay, for next for the plane wave distraction method, we apply the PWD method to extract diffraction from the pre-step seismic data. Okay, next we will generate the migrated deep angle gradient using the extracted diffraction. Then select the accurate migration velocity for diffraction in the time migration deep angle domain using the equation that I mentioned earlier. And lastly, image the diffraction using the selected migration velocity. For the coherent diffraction imaging, you also start with the raw data, then proceed with the binning, top mute, trace mute, surface related multiple elimination, and next coherent diffraction separation is conducted in order to separate the diffraction from specular reflection, and then proceed with the wavefront tomography, velocity refinement, and lastly post-step depth migration. Okay, now I will discuss about the differences, advantages, and disadvantages for these three methods. For the kickoff migration method, the diffraction hyperbola is collapsed by summing the amplitude and then placing them at the apex. It operates in the time domain. For the plane wave distraction method, it enhances the diffraction and suppresses the specular reflection. It also operates in time domain. For the coherent diffraction imaging, it performs the summation and subtraction of input data within predefined time window. It can be divided into two domains, which are data and image. For the advantages for these three methods, kickoff migration method, it has flexible and able to handle lateral velocity variation with relative efficiency. It also has cost effective. For the plane wave distraction method, it produces higher signal to noise ratio, good performance in revealing and locating the position of more complex and hidden structure. It can be used for high resolution image. PWD method does not contain reflection, so its migration did not generate artifacts. For the coherent diffraction imaging, it produces unique light on intricate fault, fracture network, and other dynamically relevant features. It gives the resolution image of lateral discontinuity, which in some sense include the dynamic history as well as past and present stress state of the crust. It also has high resolution image. Okay, for the disadvantages for these three methods, kickoff migration method has time consuming, lack of accuracy of complex structure, susceptibility to operator aliasing. For the plane wave distraction method is expensive, unable to eliminate reflection event whose loop is not continuously variable. For the coherent diffraction imaging, it has late diffraction in some region, are of plane contribution, and lastly, data-driven velocity estimation does not account for anisotropy, and smoothing does not account for the strong velocity contrast. Moving on to the current debate for these three methods, although kickoff migration method has proven to be accurate in a wide variety of image applications, but it still has few computational weaknesses such as asymptotic approximation that is only valid for large value of omega times t, where omega is angular frequency and t is travel time. High frequency approximation doubtful for near surface imaging. Weaknesses of kickoff migration also arises when velocity is not constant. Due to large frequency approximation, it can only assume large distance between diffractors and sources or reservoirs. It also assumes energy propagate at very few travel paths. For the plane wave distraction method, this issue regarding PW method will be explained in terms of figure 70 and figure 18. Although PWT method is to isolate diffraction from sharp corner, but it did not remove the curved graben as shown in the figure 18. This is due to PWD failed to remove a single point at the base of the curve feature which lacking continuously variable dip. Hence, this single point will be resulted in a circle pattern after the migration. For the last current debate, which is for current diffraction imaging, the process of diffraction is generally 3D, which can cause out of plane energy to contaminate the data with the potential to result in the occurrence of artifacts. Out of plane contribution in 2D survey are naturally suppressed if the scattering structure located reasonably far off the acquisition plane with an accurate velocity information is available. However, the less season of out-of-plane scattering can be hardly be distinguished from valuable in-plane contribution. It can be a reason why 2D diffraction-based reconstruction must be assessed with care. This can be happen to a single channel data for which a reliable velocity model might not be available. Therefore, in order to gain trust in diffraction-derived velocity information and coherent diffraction image, the mere quality of focusing need to be complemented by a joint assessment of the reflected wave field. Last but not least, for the conclusion on my study for this paper review, it can be concluded that both conventional and advanced diffraction imaging methods have their own advantages and disadvantages. Advanced discovery of diffraction imaging, such as plane wave diffraction method, is the best method to delineate and locate the position of more complex and hidden structure, while for the coherent diffraction imaging also used to illustrate the intricate for fracture network and other dynamically relevant feature by producing light. It also can give the information related to the dynamic history as well as past and present stress test of the crust. In conclusion, choosing the best and proper technique for diffraction separation is a must in seismic data imaging in order to preserve the quality of seismic data recorded as well as to accurately produce the correct location of geological structure. Lastly, some recommendation has been proposed for the future direction. The first one is the small-scale subsurface features can be demonstrated successfully if the correct advanced diffraction imaging technique is selected depending on its suitability technique for different subsurface structure. And the second one is for PWD method, considering to apply inverse radian transform to the diffraction event in order to be used in estimating the velocity model, which will emphasizing the sharp discontinuity of the subsurface structure. These all the articles that I have used as my references in doing this paper review presentation. I think that's all from me. Thank you.